Good evening, Titans. This is Mr. Sturts. We're now on lesson 4.6, Arithmetic Sequences. If you'll open your student journal, we have 4 definitions tonight. So pause the video. Make sure we get these written down. Okay, remember, we can use these definitions on our quizzes. Get these 4 written down. All right, here's our core concept tonight is an arithmetic sequence. And what we have is the difference between each pair of consecutive terms. So in a row, consecutive, the difference is the same. Okay, we can think back to maybe earlier when we talked about a linear function, the constant difference, a common difference, constant rate of change. Okay, from one number to the next is constant. This difference is what we call the common difference. Okay, so if we look at a couple of sequences here, this first one goes from negative 12 to 0. So from here to here, we know we added 12. From 0 to 12, we added 12 again. 12 to 24, added 12 again. So let's continue that pattern. 24 plus 12 is 36. 36 plus 12 is 48. And then if we add 12 again, we'll get all the way up to 60. Okay, now we're looking for a common difference in our second sequence here. What we can always do is just subtract the second number from the first number if we're not sure. So we can take 0.6, subtract 0.2 from it, and we get a 0.4. This is our common difference. Okay, so from 0.2 to 0.6, we go up by 0.4. From 0.6 to 1, 0.4. So after 1.4, we get up to 1.8. If we add 0.4 again, we're going to get up to 2.2. If we add 0.4 again, we're going to get up to 2.6. Okay, those are our next 3 terms of each sequence. We're just increasing by that common difference. Now they want us to graph these sequences. So if we make a quick XY chart, our X, we're just going to say the number of each term. So our first term is 4. Our second term is 8. Our third term is 12. Our fourth term is 16. Okay, and we could keep going. We see the pattern there. But if we go over here, let's label just our X, Y, 1, 2, 3, 4. Maybe we could count up by 2s on the Y-axis, 2, 4, 6, 8, 10, 12, 14, and we go up to 16. Let's go ahead and graph these. So the ordered pair, 1, 4. 1, 4, plot a point. 2, 8, plot a point. 3, 12, plot a point. And 4, 16. Okay, what do you notice? Well, we see that all of these lines, or all these points, follow a line. Okay, all these points would fall on this line right here. And that would continue to go on forever and ever if we kept going down the sequence. If we added a 5 and a 20, that would fall on that line. If we added a 6 and a 24, that would also fall on that line. The arithmetic sequences, they always lie on a line. So if we look at this graph, does this graph represent a sequence? Well, we see that the points are in a line. We could continue, we could connect these dots, and they follow a line. So yes, we would say yes, this does represent an arithmetic sequence. All right, now here's our equation. Okay, this is an equation for an arithmetic sequence. A sub n, what that n means, the n means the number of terms. Okay, so if we wanted the 10th term, we'd plug in a 10 for n. If we wanted the 20th term, we'd plug in a 20 for n. A sub 1, what this means right here, that means our first term. Okay, A sub 1 is our first term of any sequence. Again, n is the number of terms. And d, this is where that common difference comes into play. Okay, so we look for our common difference. Now, I think it's a little easier if we rewrite this. So in your notes, let's rewrite this formula. We're going to keep the a sub n the same. I want to rearrange it a little bit. I want to put the common difference out front. I want to put the number of terms minus 1, and then on the end, I want to add the first term. Okay, and when we do these examples, we'll kind of see why this is a little easier. We're able to distribute this d forwards instead of backwards. So either way works. I prefer this formula right here. Okay, so let's use this formula a little bit. So we need 2 things here. We need to write an equation for the nth term. Okay, nth means we don't know how many terms. It can be a variable. We can plug any number in for n. So that's in general an equation for this sequence. And then we need to find a sub 25, which means the 25th term in that sequence. Okay, so let's go ahead and write our general equation. So we don't know what n is, so we're going to leave it as a sub n. Now, using our new equation, we move the common difference out front. If we look at our sequence here, from 4 to 5 we add 1, from 5 to 6 we add 1, from 6 to 7 we add 1. So our common difference, our D, is 1. Okay, so that 1's going to go out front, parenthesis, n, again, we don't know what n is, we're going to leave it as n, and then always minus 1 in that formula, plus our first term. Now, right here, our first term in the sequence is 4, so we're going to add 4. That's our a sub 1. Okay, so just a little reminder, that formula we're using, a sub n is equal to our difference times n minus 1 plus a sub 1. Okay, that a sub 1 is 4. That's our first term. Now, we're not quite done. Let's distribute this 1 through. Okay, so distribute. We have a sub n now is equal to 1 times n is n, minus 1 times 1 is 1, plus 4. Combine like terms. We're going to get in the end a sub n is equal to n. Negative 1 plus a positive 4 is a positive 3. This is our general equation for that arithmetic sequence. A sub n equals n plus 3. Now the second thing they want us to find is a sub 25, so we need to plug in 25 for n. They want us to find the 25th term of that sequence. So what we have now is a, instead of n we have 25. That means the 25th term of the sequence. And plug 25 in right here for n in our equation. So 25 plus 3. So we find that the 25th term in this sequence is going to be 28. Okay. Now let's erase this. Let's do the second example here real quick. Same exact process. Okay, same exact formula here. So we need to figure out what our common difference is. Notice we had 8, and we had 8 each time. Okay, so our D, our common difference, is 8. So our general equation, a sub n is equal to 8, our common difference, and we don't know what n is, minus 1 plus our first term, which is 8. Okay, then we distribute. So we have a sub n is equal to 8n minus 8 plus 8. Minus 8 plus 8, that just equals 0. So what we're left with is a sub n is equal to 8n. Now, again, we want the 25th term, so let's substitute 25 in. A sub 25 is equal to 8 times 25. Well, 8 times 25, if we think about 8 quarters, we're left with $2. So we know a sub 25 is equal to 200. Okay, there's our two answers. Here's our general, and there's our 25th term. All right, last example here. We need 3 things here. Write a function that represents the sequence. We're online bidding for a purse. It increases by 5 each bid. That's our difference. It increases by 5. So plus 5 each term. Plus 5, plus 5, plus 5. After a $60 initial bid, that's our a sub 1. That's our first bid. Okay, so what we're going to do here, we need a function. So in general, a sub n. Okay, remember this is our in general function. A sub n is equal to the common difference, which we said was 5. And we leave as n minus 1 plus our first term, our initial bid was 60. Okay, again, now we distribute. So we're equal to 5n minus 5 plus 60. Combine our like terms, so a sub n is equal to 5n plus 55. 60 minus 5 is a 55. That's part A. They also want us to graph it. Let's just graph this. Rough sketch. Okay, rough sketch here. Our bid numbers are down here. 1, 2, 3, 4. Let's start over here. Let's start at 60. I didn't leave myself much room. 60, 65, 70, 75. Okay, so at 1, we're at 60. At 2, we're at 65. At 3, we're at 70. And at 4, we're at 75. Notice it's arithmetic. It's on a line. Okay, we see that it's an arithmetic sequence. Last thing here, they say the winning bid is 105. How many bids were there? Okay, we know n is the number of bids, so if the winning bid was 105, we're not going to plug it in for n. We're going to plug that in for our a sub n. That's our total. Okay, $105 is equal to, using this general formula here, we want to figure out what n is. 5n plus 55. Now we need to solve for n. So if we subtract 55, we're getting n by itself. 50 is equal to 5n. Divide by 5. Divide by 5. N is 10. Okay, so 10 is actually the number of bids that there were if the winning bid was $105. Great. Now that we took those notes, let's turn to page 124 in your student journals. Practice these 4 problems. Okay, we'll check them over in class. We'll clarify what this video talked about. Okay, we'll cement this stuff. It'll make good sense before our test coming up soon. Have a great night.